Alright, you guys, so we're going to look at question 10 and 11 on page 499 of your textbook. So kind of different problems from what we've done so far, but still following the same set of principles, okay? So I've tried to shorten this video a little bit by putting all the kind of essential and basic information out first. So in this question, we are told that we have a 4 kilogram cannonball that's flying at 18.5 meters per second at 0 degrees, so it's basically heading east. And then we're basically told that it breaks up into 2 fragments. One of them weighs 2.37 kilograms, and it goes off at an angle of 325 degrees. So I just, in order to make my triangle simpler, I just went right away and did 360 minus 325 to give me this 35 degree angle in my triangle. And so that's at a velocity of 19.7 meters per second. So right away, for both of these 2 components that we already know, I did velocity multiplied by mass to find my momentum, okay, my total momentum. Now the last component here is that we have a second fragment of an unknown mass that's flying off, and we want to solve for its velocity. So the easy part with this is obviously we can solve for the velocity because we know the initial mass of the cannonball and the weight of the mass, I guess, of the second or first fragment that flew off. So the second one is just going to be the difference between 4 and 2.37, so we have 1.63 kilograms there. Now, first step for all of these questions should always be breaking into x and y. So because our first component is only moving east, we have an x component of positive 74, and our y component is 0. When we look at the after scenario here, I just used my sine and cosine through trig to solve for the adjacent side, which is x, and the opposite side, which is y. Now, once I've solved for the number values, I do need to take into consideration whether they're positive or negative. So with this one, it's positive because it's heading east. With this one, same thing, it's still going east, so the x is positive, but because it's at a southern angle there, the y component is going to be negative. So we want to make sure that after we've figured out our numbers, we always consider whether they're positive or negative. Next step is always to find the sum of your x and y's. Okay, so remembering that your before x is going to be equal to the sum of your after x's in this case, or if you would have had more than one before, it would have been the sum of your befores is equal to the sum of your afters. So basically what we can say here is 74 was our total x momentum before, kg meters per second. And it's going to be equal to our x afterwards, which is 38.24 kg meters per second, plus the unknown component here, because we have a vbx and a vby. Okay, so it's going to be plus vbx. So if we want to rearrange to solve for VBX, we're going to do 74, and because this is a positive value, we have to subtract it off of there. So now we can say VBX is equal to 74 minus 38.24, which gives us 35.75, and then an extended decimal. For the Y, same thing, we start out with a total of 0 kg meters per second. And it's going to be equal to, afterwards, we have negative 26.77 kg meters per second plus VBY. Now in this case, because our y value is negative, to move it to the other side, we have to add it. So that means our VBY is going to be equal to positive 26.77 extended decimal. Okay. So now that we have our x and our y components, we want to make a triangle with them to solve for our resultant. So we have 2 positive values, so we know that means that our x value will be going positive, and our y value will also be going positive. So our resultant is going to go up into that first quadrant. Okay, so we're going to have an angle there. Our x component is the 35.75. Our y component is the 26.77. Okay, and so we want to solve for our resultant here, so we can just use trig for that, or sorry, Pythagoras for that. So we can say this is going to be our VB right here. So VB is going to be equal to x squared plus y squared, and then square root it, right? So 26.77 squared plus 35.75 squared. And if we square root that, we end up with 44.671 as our momentum. Okay. Now keep in mind with your momentum, what we're actually looking for in the end was velocity. So our momentum, or P, is equal to mass times by velocity. So if we want to solve for velocity, we're going to have to divide out our mass off of both sides. So the mass that we solved for part B was 1.63 kilograms. Okay, and so now we can say V is equal to 27.405 meters per second. Okay, because our kilograms cancel out. Now the only other component is that you will have to include your direction. So for theta, we have the opposite side over here, we have the adjacent side over here, and so we're going to use tan minus 1 of our opposite, 26.77, divided by our adjacent, 35.75. Okay, and so that's going to give us an angle of 36.83 degrees. So when we give our final answer, we would say that VB is equal to, rounding for sig digs, 27.4 meters per second at, or whatever, we don't have to write at, but 36.8. Oh, let me think here a second. No, because it's actually 36.8 for this one. So we got the 36.8, but we do need to, because we're given the values in polar coordinates, we have to keep that set of units. So if this is at 36.8, oh, actually that still works out because it's in the first quadrant, so it's going from 0 up, 36.8, so that still works. 36.8 degrees. And that's all we have to say because we're not using the navigator method, so we don't have to say north or east. Okay, so that would be your final answer there. I did notice that in the textbook, for some reason, they gave the angle to only 2 sig digs, but I'm not sure why they would have done that because 3 sig digs should have been the appropriate rounding. Okay, question 11. Again, similar. It's showing collisions. There's X and Y's, but really quickly I'll just walk you through. So you're given, basically you have the instance of a baseball being hit by a bat. So you're told before what the mass and the velocity of the bat is, and so right away as soon as you have that, you should be calculating your momentum. Now because it's at 0 degrees, all the momentum is in the x direction, so when you do mass times velocity, you'll get px, and your py is 0. With the ball, same thing, you're given the mass and the velocity. The velocity is at 180, so remember that's still all x direction because it's basically heading west. And so when you multiply these two together, you get px, but you have to make sure you assign it that negative value because it's going in the opposite direction. And then py is going to be 0. Now afterwards, we're going to be looking for the velocity of the bat, which means that we're going to have to, just like the previous question, we need to solve for px, and we need to solve for py. Okay, but we're also told information about the ball. The ball is traveling at 64.2 degrees, so they're using polar coordinates again there. And we had the mass, and we were given the velocity of the ball afterwards as 37.6. So if you multiply the 0.145 by that velocity, 37.6, you should get 5.452. So that's kind of your resultant, like you would see up here. And so then again, you're just going to use your sine and cosine to solve for the x component, which is 2.372, and the y component. Okay, and because they're both headed in positive directions, we can leave the number values as positive. Next step, same exact thing. We're looking at summing up our momentums. Before has to be set equal to after. And so if we look at before, we're given 2x momentums. So we have a positive 33.51 plus this negative 5.916. And it's going to be equal to, let's see, our px here, which is positive 2.372, plus our unknown px. Okay, so basically here you're going to have 33 minus 5, which is going to put you at like 28 something. And then because this is positive, you're going to subtract that off as well, which is going to put you down to 26 point something, 25. So now we can say px is equal to 25.221. Okay. Same thing for our y. We have 0 is our total before. So it's equal to, afterwards we have the positive 4.908. And so that's in addition to py, which is our unknown. So because this is positive, you would subtract it to move it away. And so we can say py is equal to negative 4.908 kilogram meters per second. Okay. Same exact step next is that you're going to draw out your triangle based on these x and y's. So x is positive, so we're going to see it going kind of over to the right. Y is negative, so this time we're going to go down. Remember, always drawing tip to tail. And then here we have our triangle. Okay, so px is 25.221, and py is 4.908. And we want to solve for our momentum, like our resultant momentum. Okay, so again, just using trig, p is equal to 25.22 squared plus 4.9 squared, and square root that, and that should leave you with p being equal to 25.694. Okay, and again, because this is our momentum, we can say it's equal to mass times by velocity. Because we want to solve for velocity, we divide out our mass. And our mass for the bat was 0.952 kilograms. Okay, and so now we can say V is equal to 26.99. Oh, meters per second. I'm still thinking in momentum and putting down kg meters per second, but it's just meters per second. Okay, so that's our velocity, and then again, solving for the angle here, we have our opposite side over here, our adjacent side over here. So we're going to be doing 10 minus 1 of, let me just see here, opposite 4.9 divided by adjacent 25.22. And so now we can say that theta is equal to 11.013. Now with this one, because we're in this quadrant 4 of our graph, we can't just use this one the way that we did before because we're in the polar coordinates method. So we have to think about the fact that this is 0, you're coming around to kind of like 360. And so we need to take this number off of 360 to find out what this angle is, like the angle that goes around like that. So we're going to say theta is actually equal to 360 minus 11.013, and that's going to give us 349 if we round for sig-digs. So now we can say that the velocity is 20. Let me just have a look at the sig-digs here. 1, 2, 3, 1, 2, 3, 1, 2, 3. Looks like we're limited to 3, so we're going to round this whole thing up to 27.0 meters per second at 349 degrees. Okay, and so that's our final answer. Hopefully that helps you guys out. That's pretty much kind of as complicated as these types of questions are going to get. So if you know how to do all of these and you just know that basic set of steps, you should be good to go.